Okay, so the Webb telescope is way out there, catching light that's been cruising for over 13 billion years. Since the universe has been spreading out, the light's been stretched too. We're talking about looking back almost to the Big Bang. You might think the universe is huge, and it is, but it all started from this tiny thing we call a singularity. Anyway, that's how we think the Big Bang happened. But the James Webb Space Telescope, JWST, has shown us some cool mysteries about how everything started and grew. It's mind-blowing. Brian Cox, this hotshot physicist, even said the JWST's big finds could totally change how we see the whole universe. Let's check out these new space finds that could change what we know. The James Webb Space Telescope, named after a top NASA guy, is like a wonder in space study. It's a huge upgrade from the Hubble Space Telescope. NASA, the European Space Agency, and the Canadian Space Agency teamed up to make it. The JWST is way better than Hubble, using new tech to check out the universe super close up. Unlike Hubble, the JWST takes really clear pics of faraway stars and stuff. It mostly uses infrared, which is cool because it can see through space dust and grab shots of stuff we couldn't see before. It's got this giant 6.5 meter, that's about 21 feet, mirror made of 18 hexagon pieces, dwarfing Hubble's mirror. It's parked about 1.5 million kilometers from Earth, circling the sun with us, so it gets a steady look at the universe. It's not just seeing light years far, it's kind of like time travel. The JWST uses infrared tools to watch stuff that happened billions of years ago. Because the universe is getting bigger, the light from these things gets stretched into redshift, moving into the infrared. Good thing the JWST can spot that, so scientists can check out how stars are born, how galaxies grow, and what's in the air around planets outside our solar system. One recent major find was spotting a crazy amount of galaxies at the edge of what we can see. This makes us question how things got to be the way they are, so we might have to rethink some main ideas about the universe. To get a grip on how we got here, let's do a quick history of checking out space. Old groups like the Greeks and Chinese started it all by watching planets move. Then, Newton's laws in the 17th century gave us a way to understand space travel. In the mid-20th century, Edwin Hubble, a big-shot astronomer, made awesome space discoveries. He saw that faraway nebulas were actually separate galaxies way beyond our Milky Way, which changed how we thought about how big the universe is and how it's growing. Hubble's law showed that galaxies farther away were moving faster, proving that the universe is getting bigger. After World War II, the space race started, with the Soviet Union launching Sputnik in 1957, the first satellite. Then, Yuri Gagarin went into orbit in 1961, and Apollo 11 landed on the moon in 1969, huge moments. Then, in 1990, the Hubble Space Telescope launched, giving us amazing views of the universe. The trips from old-school stargazing to the James Webb Space Telescope show how much we've learned about the universe. It showed us how big space is and changed some basic astronomy ideas. Like the Hubble Space Telescope, HST, it snapped the famous Pillars of Creation image in the Eagle Nebula, showing a star nursery made of huge gas and dust columns. Another cool thing was the Hubble Deep Field, which captured tons of galaxies in what looked like an empty spot in space. The HST even took a look at planets outside our solar system, finding stuff like water and organic molecules, suggesting maybe there are places where life could be. It also watched the closest supernova, SN 1987A, helping us understand how big stars live and die. All this made the Hubble Space Telescope a big deal for modern space study, wowing everyone with its huge finds. Its replacement, the James Webb Space Telescope, was launched to build on what we learned and see even more. What makes our understanding today about the origins is what we call the Big Bang Theory, that 13.8 billion years ago, it all started as a super hot, packed tiny spot, which quickly grew and made all the stuff, energy, and forces we know. It cooled down, making atoms, stars, galaxies, and everything else we see. The Big Bang Theory also explains the cosmic microwave background radiation, light elements, and how the universe is laid out. Even though most people accept it, the Big Bang Theory had some doubters at first. Some suggested other ideas, like the steady-state theory, which said the universe didn't have a start. People also wondered about the proof for the singularity, how fast things grew, and some weird stuff they saw. But most of these questions were answered over time. A big thing was finding the cosmic microwave background radiation in 1965, which matched what the Big Bang predicted. Space missions like COBE and WMAP, along with cooler tech, backed up the theory even more. The measurements of the cosmic microwave background radiation line up really well with what they expected. Then comes the James Webb Space Telescope, which has awesome infrared tools that can see through space dust. It grabs the oldest light in the universe and watches stuff that formed soon after the Big Bang. Because it uses infrared, it can focus on where stars are born and hidden from regular telescopes. Infrared light can get through dust, which Hubble couldn't always do. The JWST can also see cooler things that mostly give off infrared, which is helpful for checking out planets outside our solar system, brown dwarfs, and faraway galaxies. When things in space move away from us, their light waves stretch out, causing redshift. The JWST can spot this infrared, grabbing light from the early universe and telling us how it formed and changed. Also, big events like black holes crashing together or new stars being born mostly give off infrared, so the JWST can check out stuff we couldn't see before. It's way better at spotting infrared than Hubble, so it can see far into space and back in time, showing us stuff and giving us a better idea of how the universe grew. The JWST is like a window into the early universe. It recently found something so crazy that we might have to rethink our whole view of the universe. We've spotted huge groups of galaxies at the edge of what we can see. These galaxies were around just a few 100 million years after the Big Bang. The mind-blowing part is we don't know how such big things formed so early. This might make us rethink how galaxies formed and grew in the early universe. Checking out early galaxies is key to figuring out where everything came from. The JWST can help us learn how galaxies, stars, and planets showed up and changed over billions of years. These observations also help us answer bigger questions about the universe, like what it's made of, how it's set up, and what forces control it. While the Hubble Space Telescope was amazing, it had problems seeing the early universe. It couldn't see through space dust well or spot the infrared light from old galaxies. Older telescopes used visible and ultraviolet light, so it was tough to check out the early universe because dust and gas block or mess with those wavelengths. The James Webb Space Telescope is a huge jump in seeing galaxies from the early universe. Unlike old telescopes, the JWST can see stuff that formed within a few 100 million years after the Big Bang, using its infrared and cool cameras. The JWST has found a ton of old galaxies, giving us awesome clarity in understanding how the universe grew. The earliest findings from JWST have caused scientists to rethink established cosmological models. The detailed data challenges lots of the current theory, nudging cosmologists to examine the building block of our understanding of cosmic evolution and structure. Differences between observed data and theoretical predictions have sparked arguments within the science community. JWST observations have revealed a larger number of galaxies in the early universe than anticipated by existing models, hinting at a more complex and rapid evolution process. Some observed early galaxies appear more developed than expected, challenging conventional models predicting slower development. The discovery of an unfathomable mass of galaxies challenges the assumed distribution and arrangement of large structures, revealing a more intricate and denser cosmic web than previously thought. These observations raise fascinating questions and avenues for exploration. The existence of large structures challenges early models of cosmic structure formation, prompting researchers to refine models for a better explanation. Understanding how such vast structures gathered rapidly after the Big Bang presents a puzzle that requires an explanation that doesn't violate building blocks of cosmology. Differences in the conditions of the early universe compared to predictions based on existing models have also been revealed. The variation could suggest unidentified cosmic happenings. In plain, these changes have moved scientists to improve our models of the universe. Currently, all we can say is that exploration is needed to incorporate the observations in a more complex understanding of the cosmos. Starting observations often give inspiring glimpses to the universe, but overlook, they might reveal differences. The examinations might show properties or arrangements within far galaxies which further and reveal changes to composition. Enormous happenings require careful testing for us to understand their true nature. Testing that objects are made out of is a good example. It involves reviewing the light that makes it, which gives data of the temperature, density, and movement. These analyses help us what it made of and how stars came about over the cosmos. The JWST has found where initial observations differed from investigations in galaxies, for example, suggested simple setup with light elements with what the galaxy predicted, where it show variation in elements which show compounds that were not detected. This tests the ways of the illusory parts of the universe and their part. Similar initial assumptions were made with patterns, however JWST revealed different arrays of chemicals within the galaxies. JWST continues to redefine understanding for the cosmos by seeing what has been hidden from our universe before. One of the many cool things is that it can study worlds outside our own in ways we have never done. By studying what they breathe, it can show new chemicals such as carbon dioxide, water, and other things. So we can see if there is something that can hold life. In addition to new worlds, the JWST has changed how our star came by. The telescope can newborn star in areas that have dust and gases. By finding light to darkest corners, it will show how plants are made, giving how stars are made and will evolve.